So James Simmons has been an active Linux kernel developer since 1999. This development has been from small embedded systems to large supercomputers. James Simmons has been active in the Luster community since joining Oak Ridge in 2008.
Good morning. So I wanted to give another talk on the native Luster client, which has been an ongoing project for many years, and this is the second time giving this talk here. So where we're at. So the thing about this project is it's one of these projects that won't die. So it's one of the oldest projects around. It's over 8 years old. Mainly it's been going on for that long because it has gone through stages of progress and stages of languish where we didn't have much going on. So, and for example, one of the points was it was upstream. It got removed from upstream because they viewed it as lack of involvement because there was only at that time it was just me. Also, it was initially pushed to the staging tree, which was the wrong fit. So in the Linux kernel, the staging tree is this ground where your driver is pretty much ready, and it's just there to go through the final stages of cleaning and meeting the Linux kernel standards, and then it's integrated. But Luster is like one of these active projects where you have thousands of lines of code changing every week. So it's not really a great fit. So after it was removed, we had discussions with Neil Brown and with the VFS guys, and we said, well, it's better just to put it in the FS directory with all the other file systems in the next go around. So, and also it's just limited resources and limited support for this project. So as we know, it's very expensive to, when we were talking about Ubuntu, and I was describing how much is needed to do testing. You don't realize there's hundreds of VMs. It's a huge process to do tests. We have thousands, tens of thousands of tests done for every patch. So as patches come in, you multiply that and you run into millions of tests being executed at any moment in a test rig. So you need a huge structure to do this kind of testing. And because of that, and then you amplify that by LDiskFS and ZFS, those matrices and all these distros, and it spirals out of control, and then versions. So because of that, everybody in the community focuses on different tests. Like ARM does their own testing infrastructure. Ubuntu is done by the community, various volunteers, and then of course WhamCloud focuses on Rails support. But the good news is, though, even with all the limited resources, there's been always community involvement, and it's kept this project alive. So over the years, Oleg from WhamCloud kept it alive for several years. Myself kept it alive. There have been various, over time, people revolving in and out who have contributed to the project. Like Arleon from Amazon contributed a little bit, and also Sean Touchaf from HPE, he did a lot of work for kernel and support for newer versions. So it's been a good project, and then of course Neil has been involved with it for several years. The good news is that we've been really close to completing this project now. So we've synced it to the OpenSF tree. It's been like that for well over a year now. So everything, all the functionality you see in the latest master is actually in the native client tree that exists. The goal is to actually submit this back up to Linus when IP version 6 work is done, which will be at the conclusion of 2.16 development cycle. So we're looking by the time of the next slug, this is going to be pushed to Linus, and we're going to see what the community feedback is, and then go through that process to merge it upstream. So where have we been over this last year? So of course, like I said, we've been in sync with master, and it's been kept in sync to this day. We have finished the flow now that the native client is equivalent to the OpenSFS. We've had this flow of a lot of work that was done on the native client that was independent of this from the Linux community when it was in the staging tree. So we've been going through that. The good thing is that a lot of the development for newer kernels is done there first, and then it's backported to the OpenSFS branch. That also means things like any OFED changes, because OFED is always tracking the latest thing. We end up encountering that before the OpenFSS branch, and then we can backport that for them. And the other benefit is, of course, support for new distros. So like in this last development cycle, we were ready before Ubuntu 22 and RHEL 9 was out. We just had support for this stuff. We were already developing and it was all landed. So it was just, as soon as it came there, it was ready for broader testing. We also saw various performance gains. So there was some work like during the 2.13 cycle, and like we found like our hash table implementation performs way better than the libcfs hash table implementation. So we get all these performance gains. We broke up various locks and the complexity of the LU object handling. So there was all these nice little pro benefits to it. As it currently stands, we're at a 5.9 kernel. And I have a patch that I'm developing to get up to 5.15 for the native client. So that patch is still in the work. So the biggest complexity right now is the way Lustre handles its embedded FS crypt and the native crypt. They've reworked FS crypt several times. So, and right now one of the biggest changes is because FS crypt for the 5.4 version up to 5.10 didn't properly support. If you know memory allocation, there's a special flag called GPF no FS. That's not properly supported by FS crypt. So they had to go and rearrange how they allocate it and built a file system encryption context. And it's quite a bit of work. So I've tried to do that, and I'm piecing out those bits. And as I pointed out right now, it's so once that's resolved, we'll jump to 5.15, and then Sean from HPE has been working on even newer kernels, so there's patches for that. So I can go and test those as soon as I'm done with the FS crypt stuff. And as I pointed out, it has been a great community effort. Neil Brown from Suzy has been doing a great job. He's been driving a lot of the IP version 6, and of course myself. And I also have been working on the IP version 6 with that. And of course, there are many others who have come and gone, and I'd like to thank those people who've contributed to this project. So how healthy is this native client? So we do the same testing as like ARM and Ubuntu, so that's usually covers LNet self-test and sanity testing for light testing. And of course, I actually do heavier testing locally, and so I've been testing any of the config sanity and stuff, and I find that it's pretty much comparable to what we have. It's pretty much the same bugs in both trees. There's a couple exceptions, but mostly for the most part. Now the nice thing is within the last 12 months, we've made it so that the OpenFS tree utilities, Lustre, you can actually build the utilities to work with the native client. It just works out of the box. So if you do configure and you disable server, you have an option called disable modules. And when you do that, it just builds the utilities for you, and you can just install it with the native client and it works. It's that easy now. And with this, we can now do automatic testing. So as we saw over the last 6 months, ARM has been working on doing this, and we gave a presentation at LUG about this. And I've been following and talking with ARM how they're doing this. So this way, for the native client support, we can move to this kind of testing ourselves. We just have to work out a test system, and at Ornell, we've been discussing about using like a cloud service provider to build our own testing rig to do this. And so probably the biggest bugs that we see in testing is the FID lookup cache. So that's been a complex bug that's actually more difficult to solve than you think. So, and the F handle stuff is not quite correct in its behavior currently in the Lustre code. So I've been trying to figure out how to fix that, but it's a touchy one. And I haven't had the time to do that because I've been focusing on other issues. And over time, we've been resolving any bugs that have handled. The most common thing that does happen is occasionally, because we don't do a test build with the OpenSFS tree against the native client. Occasionally we get UAPI breakage, so this is the userland header stuff. So occasionally something will leak in and it doesn't quite, it'll do some kind of build breakage. It's not often. Like the most recent one, which is going to land very shortly, is that HPE landed their support for their new LND driver, the K-Fabric stuff. And of course, we don't support that upstream. There's a lot of licensing issues to support that upstream, and that it's not in the native kernel, so it doesn't build. So I had to make a patch that says, well, okay, we don't support this driver. So what are the final touches? So there is a big ticket to cover all this. This is LU 12511. It tracks all the work, and you'll see there's like 50 open subtasks. Most of those are closed, so actually. There's a couple big items left. The largest is being the IP version 6 work. A good chunk of that was done during 2.15, actually. If you look in the code, a lot of the infrastructure was landed. It's just a lot of the outward interfaces and the wire protocol wasn't done at that time. The IB support, as Andreas pointed out, that needs to be resolved during this time. So one of the things is our InfiniBand driver is extremely large. It does a lot of its own handling. So in newer kernels, for when they did the OPA drivers, they required that they would do a generic RDMA API, and a lot of those drivers have been moved over to that API to make the driver much smaller. So they requested that we would do the same thing. They would like to see our InfiniBand driver to be only about 500 lines of code instead of, the 5,000 that we have right now. And of course, we keep, as testing expands and as we keep moving forward and these newer features land, we keep testing to make sure. And one of the unique things about it, much like ARM, there are strange bugs that are found only on the native client that you'll never see. There are things I can reproduce. Sometimes one client will say, oh, we have this bug, but we hit it in 1 in 100 runs. And I'm like, I can see it every single time with the native client. And that's because there's some timing issues because we don't have all the debugging infrastructure that the native client relies more on the debugging features that the kernel natively provides instead of the special debugging features that the OpenSFS tree does. And because of that, that changes the timing mechanisms of a lot of the debugging code, and that exposes us new types of bugs. So what are the biggest bugs left? So one of the biggest changes is actually the proc handling. So in the Linux kernel, everything's being moved out of proc now and being moved to sysfs and debugfs. So that was a big change. So the native client already has everything moved over to these things. Where OpenSFS, we've been gradually moving it over because there's some side effects of moving it over to these trees. So one of the biggest side effects is the debugfs system. It's considered not a safe area to use, so it's not generally allowed to use to non-root users. And so that broke things like lcuddledl and the stat stuff in the upstream client. So when we came across that problem, one of the inspirations to solve that problem was something that I discovered that the Android phones actually encountered. So Android at one time, how your proc tree, you could actually look up the statistics of of all your applications. You could look up your task IDs and stuff like that. So Android phones used to do that and scan the entire proc tree, and they found that it would drain the battery in less than an hour doing that. So they realized that they needed another solution that was less CPU intensive. So they actually developed something called task stats, which is a Netlink API, and they found that the performance was many-fold times better. So actually, we are looking to replace a lot of the debugfs stats with a Netlink YAML API, which Monday with the developers, I presented how to do that. So this is actually going to give a huge performance win. Instead of opening thousands of proc files to get your stats, you'll only have to open a single Netlink socket, and it'll download these YAML data structures for you, so you can parse them and do whatever you want, and it interfaces with Python. There's all these benefits with that. The other issue is that the SysFS has strange naming conventions. So when you look after you mount it with your, when you do your LCLGit params, you see this long number string. Well, technically that's a security violation because that's actually exposing an address pointer in the kernel space, and that's considered, it's called ASLR, and it's considered a big no-no. So we need to change that. So we discussed about changing that to new fields, and our tests are ready actually for those changes. And so those are the changes for that. The other one is moving to R hash tables and X arrays to replace the libcfs hash table implementation. And of course, as I just pointed out, the ASLR compliance. We've reworked the mount code. So one of the changes you're going to see is that mounting servers and mounting clients is slightly different. Currently, you can mount them as a type Lustre, but there's a new type of mounting configuration for servers. And there's a reason for that. And of course, the FID lookup and fhandle fixes that need to be done. So what are the visible benefits that you can already see in 2.15? There are some benefits that came out of this work. So every changes that we do, I look to see what can improve the life of the user. So one of the things with SysFS is you can do UDEV rules now. So like our frontier system, this is one of our rules that we put in place. So we can auto-configure as soon as the modules come up, and we can run our own scripts. So instead of just doing your classic lcutl set param, we can do all this elaborate work. Also out of that, we can do client eviction reporting. So there is actually some work being done on that. I want to land that for 2.16. So when your clients can get evicted, it will actually send you a UDEV event. So you can actually write scripts to log that this client's done, or you could actually try to reboot your client. This can be all automated. So as your systems fail, you can actually try to like resuscitate them. I like to call it the CPR system. So, and the other plan is actually to do this also with LNet HealthNet events. Right now we have health events and it takes it down, but there's no notification of like when LNet has a hiccup. You find out after users start complaining that their applications are sick. This would allow you to actually know as soon as something is going wrong. You would be notified. You could end up having scripts. You could end up automating a system that tries to recover as soon as these events happen before you find out from the user. Other benefits is we want to unify the names, the SysFS naming space with UUIDs. So, in your traditional file systems, you can mount it by a UUID, which is consistent across reboots. Currently, you don't do that now. Currently, SysFS with our UIDs, they're unique to each node. So it would be nice to have that consistent around there. So your each mount instant would be consistent every time you mount it. You could write scripts and you would know, oh, this is my UUID for this mount. So you don't have to do just star. You can actually use the proper UUIDs. The mount targets have changed for the servers. So there's now a mount-t Lustre target. It's not just Lustre. And the reason for that is that we're inverting the way the structure works for the mounting code. So currently when you start Lustre, the LNet layer comes up, the portal RPs come up, and then mounting happens. Work has been done to reverse that, so the LNet layer doesn't start up instantaneously. It is only on mounting that the LNet layer comes up, and then it starts to do the protocol. And there are some reasons for some benefits to that, because one of the issues we've had in the past and we've seen is that you have all this network traffic coming, and then when you try to on-mount, it kind of can't on-mount because the traffic is still coming. So in this case, when you go to on-mount, it tries to drain the queue then. It's a different order for that. And of course, there's work that's going to be done on fhandle. We're going to properly support that API. Same with file sets. That's been broken for a long time, and Ornell's wanted that for security enclaves. We're looking at GenRadix trees for allocating large data sets. So one of the issues that we've seen, and this is a new API that was developed in later 5 kernels. And so one of the issues we've seen is that vmalloc will tank performance for large data sets that are allocated constantly. And of course, the last thing that we're going to do is the migration of stats handling to Netlink. So with Netlink, there's a huge amount of benefits over the current methods of gathering stats. And then down the road, there will be the ability to configure your stats to only report stat fields you want. There's a lot of opportunity there. So probably the biggest changes, and probably the one that's of most interest to people, is the LNet changes. So we're going to see IB version 6 support, and not only IB version 6 support, but also IB hardware addressing support. So you'll be able, that's a 20-bit address, so you will no longer need to set up a TCP stack on your IB. You'll be able just to talk to the remote hardware addresses. We've gotten to the point where, as you can see, we can actually bring up IB version 6. Last week, we're just getting that. We're trying the ping code. The ping code, I found, has some issues because it has not been tested before, but now we're getting testing, so we're working out the bugs for that. And then from there, it'll be easy to send the protocols for the data itself. The other thing is this new IB version 6. So there are roughly 60 ioctals that are used for LNet. Some of them are non-multi-rail, and some of them are multi-rail. And with IP version 6, that means that we would have to double all the ioctals and rewrite them. So what I did is that's why we're using the Netlink API with YAML. So that gives us the benefit to replace all those ioctals and use one API for everything. So it's completely backwards compatible. The other nice thing about that feature is that the API can change all the time. I've written it so that the API is backwards compatible indefinitely. So if you want to add a new feature, it won't break the old tools. And if you are running a new tool with an older kernel, it won't break. You just can't break it. I made it pretty resilient for that. And of course, LNet self-test is the same way. So I am not a fan of the current LNet self-test. I found ways to crash my nodes with it in so many fun ways. And one of the things that I hate is the scripting interface. So it's going to be YAML based. You will be able to create YAML configs and feed it to LNet self-test. No more typing in every single line to execute it. We will still support that, but in the background, it'll be creating the YAML file for you to send up at the end. And another nice feature will be using LNet discovery for mounting. So theoretically, you won't have to set up LNet. When you go to mount, it'll use discovery and it'll scan your network interfaces and bring it up for you. So the days of setting up and configuring your LNet and then mounting, they could be over for you. So that's probably going to be a huge benefit. The only thing you'll have to do is do blacklist to make sure that interfaces you don't want to do don't come up. So those are the things that are going to be looking forward once 2.16 is done. So what does the future hold once all this work is done? So once it's merged, you're going to see it in distros. So, and who's going to support this? Well, of course, SUSE is involved in this work, and SUSE is concentrating. So when they go to do their test rigs and do full support for Lustre, they've decided they only want to do the native client. They don't want to do the OpenSFS tree. They'll be going immediately to that. And as for Ubuntu, that's the closest to upstream, and there's heavy demand, and even from the last discussion, we see that there is a large interest in the community to support this. So Ubuntu will probably be still a community-supported effort. We'll have to figure out how to, once we figure out how to do an external tree, we're going to have those bugs reported to WAM Cloud, like ARM is trying to do. And of course, one of the biggest benefits of this is to get new developers into the community. So this is a big thing. And of course, the other thing, one of the other big benefits is Lustre does tend to develop new things, like Sebastian did FS Crypt, the performance gain. So I did submit that to them, and they currently said we're not interested in it because there's no real users. When Lustre gets merged, we'll consider it then. So when we get merged, they will get this work. And then in the future, whatever we want, there's a bargaining tool for this. Then, of course, this is the last time I'll probably be discussing the client work here. The next step will, of course, be moving the rest of the tree to the upstream kernel. So that means no more LF-diskfs patching. I know there's probably hand claps for that, especially on the Ubuntu people. So that we'll be able to get LDiskFS and ext4 will merge. And of course, everything that we're doing in the OpenS tree to support the native client is already being done. So it's a very small step. It's not going to be a multi-year process. We're talking probably a year to move the rest up. And then, of course, there's always the welcoming of community involvement in this project. So as we gladly welcome anyone who would participate, like before we have rotating support, as we prepare for the merger in the 2016 timeframe. So we're looking by April or May to submit this upstream. And of course, we need greater scope of testing. And there's the URL for where to grab the latest tree, and there's information how to test it. And of course, welcome to open bugs if you test it. I know Nate Ruttman from HPE tests the native client. He's shown an interest. And of course, you can ask questions on the Lustre development mailing list, or the LWG. We always discuss it at our calls, or you can discuss it at these Lustre conferences. And then in inclusion, we're pretty much close to done. This is my last slide talk on the client stuff. And of course, don't be afraid to ask questions, join calls, mailing list, report issues, or you can contact me directly about this project. And I would like to acknowledge Oak Ridge for the support of this project. Without the support, this project would have probably died many, many years ago. Thank you.
Thank you. Any questions for James?
What's the status in upstream versions? I mean, Red Hat 8 and future Red Hat 9?
So you mean like what will be the next version, distro versions will support?
So today, using Red Hat 8, what's the current
So
status?
I do testing for my system. I have a modified RHEL 8 and a Ubuntu 22 system running those kernels. I run the native client on that. For the reason is Ubuntu 22 supports fscrypt natively. RHEL 8 doesn't. You have to like build your own. But yeah, I've been running modified kernels on those.
And for upstream, to have it upstream on non-modified systems, is this planned or is it for a future version?
It'll be for a future version. So to merge it, we're going to have to sync up to the very latest wherever Linus is at, and then merge it during those merge windows. So we're looking probably somewhere around 6.2, 6.3 kernel.
Okay, thank you, James.